Unit 3.13 Beer-Lambert Law. A student measures the absorbance of a solution containing FeSCN ion using a spectrophotometer. The curvet used by the student has 2 frosted walls and 2 transparent walls. The student properly orients the curvet so that the path of the light goes to the transparent sides of the curvet when calibrating the spectrophotometer. How will the measured absorbance of FeSCN be affected if the student incorrectly orients the curvet so that the path of the light is through the frosted sides of the curvet? So what this problem is saying is that the curvet is gonna look like this, and it has frosted sides and the clear sides. And so the frosted side is gonna be something like here and here, while the clear side is gonna be something like here and here. And this problem is also saying that what will happen if the student incorrectly orients the curvet so that the path of the light goes to the frosted sides of the curvet. So what they're gonna do is that the light, so this is gonna be like the light, and the light is gonna travel to the curvet, which is gonna look something like this. And there's gonna be like a detector over here. Detector. This is curvet. So before jumping into this problem, let me explain what the spectrophotometer is. So what they do is that the light is gonna travel to the curvet, and what the detector does is that detector is gonna determine how much absorbance, like how much the solution absorbed the light, basically. So how much the solution in the curvet absorbed the light. So the solution in the curvet is gonna be FeSCN in this case. And so if light just travels through and just like doesn't get absorbed by the FeSCN at all, the detector is gonna know that the measured absorbance of the FeSCN solution is gonna be like much lower, because that means that the light just went through. It didn't get absorbed by the FeSCN at all. So, but then what the problem is saying is that if they oriented the curvet so that the frosted sides is gonna like face the curvet like this, like if the frosted side is like over here, like what will happen? So before there was just transparent wall, but then now there's like a frosted wall over here that's like blocking the light travel, and they're asking what will happen. So what will happen is that the light is just gonna travel and it is gonna be absorbed by the frosted side, and like the light is gonna be more scattered by the frosted curvet. And what the detector is gonna know that since the light is not traveling to the detector at all, they're gonna just conclude that the measured absorbance of FeSCN is gonna be higher than before. Like FeSCN solution is gonna have higher absorbance than before. And so knowing that the frosted side is gonna make the absorbance of FeSCN solution like much higher than before when there was just transparent wall, let's take a look at the answer options. A, the measured absorbance of the FeSCN solution will not be affected. That is not true. The absorbance is gonna increase than before because the light is just gonna be absorbed by the frosted side, and it is gonna get affected by the frosted side. And B, the measured absorbance of FeSCN solution will be higher than actual absorbance. That is true. And it is higher than the actual absorbance just because of the frosted side, and it is kind of blocking the light travel to the detector. C, the measured absorbance of FeSCN solution will be lower than the actual absorbance. That is not true because it is going to be higher. D, the effect of the measured absorbance of FeSCN solution depends on the concentration of the FeSCN solution. That is not true. That is like not the focus of this problem, and that is just not related at all. This problem is talking about the frosted side and what the frosted side is gonna do, not the FeSCN solution or the concentration of the FeSCN solution. So the answer for this problem is gonna be B.